So for our last new topic in this unit, we're looking at the relationship between sine and cosine of complementary angles. So if you recall, complementary angles always add up to 90 degrees. There are a total of 180 degrees in any triangle, and a right triangle must have a 90-degree angle. The reason why I'm telling you to remember these things is because if you look at a right triangle, and you know that they must add up to 180 degrees, right? If you know that one of the angles already has to be a 90-degree angle, then you're saying that the last two angles must add up to 90. So for any right triangle, your two non-right triangles are going to be complementary. So in a right triangle, if B is the right angle, then A and C are complementary angles. Fill in the following table with the ratio of lengths. So sine of A is equal to BC over AC, because this is opposite over hypotenuse. Sine of C is AB over AC, because this is, again, opposite over hypotenuse. When we do cosine, we're doing adjacent over hypotenuse. So AB over AC, and then we have BC over AC. Now, if you notice something, each ratio is repeated twice. If you look, the sine of one angle is equal to the cosine of the other. So any acute angle is equal to the cosine of its complement. So if A and C are complements, then sine of A is equal to cosine of C. So if you have two angles, so M and N are 30 and 60, 30 plus 60 is equal to 90. So then you know that since there's complementary, the sine of one angle is equal to the cosine of the other. And you can even see that in the table we did above, right? If you replace this as M, right, sine of M is BC over AC, cosine of N is BC over AC. They are the same. So find the value that would make each statement true. If we're saying that the sine of X is equal to the cosine of 25, then these angles must be complementary. So 90 minus 25, which gives you 65. Same thing. 90 minus 80 is equal to 10. Here, x plus 10 must be equal to 90. If you solve, 2x equals 80, so x is equal to 40. Again, x minus 45 plus x equals 90. So we have 135 divided by 2. X is equal to 67.5. Again, if you're saying that sine of something is equal to cosine of something else, then those two angles right here have to add up to 90 degrees. In right triangle ABC, with the right angle at C, expressions for sine A, cosine B, cosine A, sine B are given below. In each example, determine and state the value of x, right? So these are two different angles, and we're looking at sine and cosine. So we know that these have to be equal by the theorem that we're doing. So 0.8 plus x equals 0.4 x plus 3.4. 0.4. Oops, hold on. Let me rewrite this neater. 0.8 plus x equals 0.4 x plus 3.4. If I move 0.4x over, I have 0.6x. If I move the 0.8 over by doing 3.4 minus 0.8, I get 2.6. And then I divide by 0.6. I get x equals 4.3 repeating. Same thing, different angles, different functions, so I can set them equal to each other because I know they must be complementary. So we're going to get that x is equal to 0.4. So again, here, 6a plus 9a must be equal to 90. So we have 15a is equal to 90. A is equal to 6. And scaling triangle ABC, which equation is always true? So again, you're looking at the different functions, and then it's the two different angles, right? So it's not going to be anything that has the same. And now the only thing you have to make sure is you're not using the right angle. So you're left with 4. So we have different functions, different angles. What is the value of x? So 40 minus x plus 3x must be equal to 90. So we have 2x equals 50. X is equal to 25. So again, draw your triangle, M, T, R. So it has to be two different functions, which they all are. It's not going to include the right angle. And it has to be two different angles, so it's going to be 3. Which expression is always equivalent to sine of D, right? So if we're doing our normal with just 1, I'd be looking for cosine of O. But if you look, there is no cosine of O, right? But you know you're looking for cosine, so you would have to eliminate the sine of the tangent, because the corresponding here would be C, and there's no sine of C. So now you're looking what matches with O, A. So those are the same. Again, the two angles have to add up to 90 degrees. So we're saying 6x is equal to 90. So x must be equal to 15. So they're saying cosine of b is 5 over 13. So again, different function and different angle. Different function, different angle. They are equal, so you're just going to pick the same thing. Which expression is always equivalent to sine of x when x is between 0 and 90? So usually it would be sine of x is equal to the cosine of the opposite angle. Well, these angles have to add up to 90, so it's whatever is left when you take away x from 90. Sine of 57 would be equal to cosine of whatever angle adds up to 90. Clearly it's not going to be 57, so it would be 2.